Hey guys, sorry I couldn't make it today. A couple of things happened over the weekend. I just wasn't able to get to work today, but I should be back tomorrow. Um, Today should be quick and easy. I'm gonna go over a problem basically to recap what we did on Friday, particularly for some of you who weren't here on Friday. And then I'm also going to go one or two problems on the back of the worksheet that I gave you on Friday, which have problems where you're given a graph and you have to determine what the equation for that graph is. Okay, so what we're going to start out with is we're going to be given an equation and then we're going to turn that into a graph. All right, so let's start out with number 6 on that worksheet that we had from Friday. Okay, the one that has all the equations on it. It reads graphing trig functions at the top. Okay, it's the one where it's asking you to sketch two periods of a graph for each of the following functions. All right, now I don't have the actual worksheet in front of me, so I'm just going to write these out on a piece of white paper. Okay, so just follow along and make sure you take good notes. If for whatever reason you're still confused after I talk about this, make a note of it somewhere in your notes. Put a sticky note on something and come to tutorials like either in the morning or after school tomorrow, and then I can answer your questions there. I'll try my best to recap things in class on Tuesday, but there might be a chance that we might need to move on in class on Tuesday. So if you don't get it today, make a note of it, and hopefully I can explain it in a couple minutes before school or after school. Okay. So let's start out with number 6 on the front of the page. Now number 6 reads as follows. Okay, number 6 says y equals, okay, and we're given -8 minus sine, so -8 minus sine, and then it says pi x minus 0.5, so pi x minus 0.5. okay, and the way it's written on the let me try to focus this a bit. Okay, the way this is written on the worksheet is kind of confusing because we've never seen this notation, and so I mentioned on Friday that all you have to do is add another set of parentheses, and all this pi is saying is just distribute this and we would get the form that we kind of started out with. Okay, so the form that we started out with also didn't have the sine axis or the d piece, right, out in front. So instead what we're going to do is we're going to move the sine axis to the back of the equation just so it kind of looks like the ones that we've been doing. So this one says negative sine, and we're going to go ahead and distribute. Okay, so it's going to be pi times x minus, well, pi times 1/2 is simply pi over 2. Okay, then we're going to subtract an 8, move the -8 to the back. Alright, and now we have an equation just like the one that we started out with. Alright, now what you'll also notice about this one is that the negative sign is, well, that the sign is a negative sign. Alright, so we haven't seen a negative before, but you know from algebra that whenever you have a negative out in front of like an x or an x squared, what that does is it flips it across the x-axis, right? So you can use this form, but the original form that the worksheet gives us is actually a little bit easier. Okay, so I'll explain right now exactly why that is. Alright, so in particular, one of the reasons why this notation is a little bit better is because it's gone ahead and factored out or really solved our total phase shift. Okay, so our total phase shift was the C part of our equation, right? The C part. And so over here what we would have to do is we'd have to take C and divide it by B to get what our total phase shift was. Okay, So let's just kind of label out all of the pieces that we have. We know that our A piece, our A piece is going to be equal to, in this case, -1. Now, specifically, when we were talking about amplitude, we said that it was going to be the absolute value of this, right? And so, really, our A is only 1. However, that -1 is going to be important later on when we start graphing, because it's going to remind us that we're actually going to flip. So rather than starting out with a sine equation at the origin that goes up and then down, right? What we're going to have is we're going to have a sine equation that will go down then up, okay? So we're going to have something that goes down first rather than up. Our B piece is pi in this case. So far, I mean, our pieces are essentially the same. We have the amplitude of 1. We have a frequency of pi, okay? And then here's kind of where it changes, right? Because our C piece is, in this case, pi over 2, okay? However, we said that in order to calculate the total phase shift, okay, our TPS is what we've been calling it, our total phase shift we said was absolute value of C divided by absolute value of B, which in this case would be, pi over 2 divided by pi, right? And so you gotta remember that whenever we're dividing these, you have a fraction on top of a fraction, and even though the bottom doesn't look like it's a fraction, you have that 1 underneath, right? Okay, so we have this 1. So what happens is when we're dividing fractions, we're actually multiplying by the reciprocal of the denominator, right? So we have pi over 2 times 1 over pi, and so what we get here is we can cancel out the pi's, okay? Which gives us a 1 and a 1. They reduce to 1 over 1, right? And so when you multiply fractions, top times top, 1 over bottom times bottom, 2. Okay, so our total phase shift is 1/2. And when they factored out that pi in the original function, what they gave us was actually the total phase shift already from the start, okay? So they've still given us our D value, they've given us our A value, they've given us our B value, and they've given us our total phase shift. And remember that your total phase shift, we said before, was kind of like your starting point. Okay, we said that it's essentially going to start at 1/2, and because we are shifting to the right, we're actually going to start 1/2, a positive 1/2 on the x-axis. All right, and then last but not least, we have a vertical shift of 8 units down. Okay, so remember your D was vertical shift, also known as your sine axis. Okay, so let's write that down. D was 8 in this case, which we called a vertical shift, right? That's what we called it in algebra. But we also said that it's called your sine axis. And the reason it's called your sine axis is because we said that that's the axis along which this sinusoidal wave is centered about, right? It's kind of like the halfway point of the top and the bottom of the curve, okay? So we also call it the sine axis, okay? Remember that B is your frequency, and that A is your amplitude, okay, and that we called C your phase shift or horizontal shift, right? Okay, so we called it your horizontal or your phase shift. Another thing that was very important when we were graphing, we said, was to find the period t. Okay, so t in this case, remember, t is always 2 pi over b. So in this case, it's going to be 2 pi over pi. What's nice about that is that your pi's will cancel out. So you're left with a period of 2. Okay, and we said that whenever you have a frequency that's in terms of pi's, you will always have an x-axis that is defined in units that aren't radians or units that are not degrees. Instead, they're going to be numbers like integer values, or in this case, we might see that they are decimal values. Okay, so in this case, we have a period of 2. All right. The other thing that I mentioned was that whenever we were trying to find what our increments for the x-axis were, that we wanted to find numbers that played nice with b, right? But then on Friday I told you that it's actually a lot easier, right? Because we can figure out what the increments for your x-axis are by taking the period and dividing by 4, right? So in this case, we're going to have a period of 2. We're going to divide by 4. So we should have increments of 1/2, or if you would rather, 0.5. Okay. And we said that the reason for that was that when you draw your sine wave, right, there's going to be 5 key points. And that's why we always had 5 points in the table. Okay. You're going to have these 5 key points. And what's important about those points is the distance between the first point and the last point. That's your period, right? Okay, but we said that if we just divide by 4, we'll get 4 equal increments, right? So you have 1, 2, 3, 4 equal increments between each of those nice points that we want to graph, okay? And so that's why we're dividing the period by 4. So in this case, because our period was a length of 2, that means that each one of these will be a length of 1/2. Okay. So let's go ahead and kind of start to graph this. Okay. So we can kind of start our we can definitely start what our graph should look like. Okay. And we know that we said that we're going to have a period of 2. We're going to have increments of 0.5. We need to graph 2 periods. So we should probably go out to 4. But we know that our starting point is 1/2, right? Or 1/2. Which means that we should probably end at 4.5 somewhere out here, right? So we're going to do increments of 0.5. So that's going to be 1/2, 1, 1.5, 2, 2.5, 3, 3.5, ran out, 4, 4.5. Okay. And so our starting point tells us exactly where we're going to start. And because we're shifting to the right, that's how we know that we're going to start here at 0.5. Okay. This will be 1, 2, 3, 4, and then 4.5. Okay. The other thing that's going to help us graph this is we need to figure out what the amplitude is, or not so much what the amplitude is, but what the range is going to change by. So one thing that'll definitely help us out here is to remember that the range of sine of x, because we're dealing with sine, the range of sine of x was from -1 to +1. Okay. And now the things in the equation that will affect our range are going to be things like the amplitude, and the other thing that's going to affect our range is going to be our sine axis, or our vertical shift. Okay, so the way you want to convert your range to the current range that we have is we want to first multiply by the amplitude. So we're going to multiply by -1, so to speak. We're going to multiply by a -1, because you got to remember that we're going to flip and amplify, right? But in this case, because we're only amplifying by a factor of 1, really all we're going to do is we're going to flip these. So we're going to take -1 times -1 will give us +1. 1 times negative 1 will give us negative 1. Okay, the next thing that you want to do is you want to add the sine axis value to it. Okay, so we're going to take the sine axis and we're going to subtract 8 in this case, right? Because our sine axis was minus 8. So we're going to subtract 8 from 1, so that'll give us negative 7, and we're going to subtract 8 from negative 1, which will give us negative 9. Now, the way range and domain are always written is that they're always written from least to greatest. So because this flip kind of flipped the numbers on us, we got to make sure that we write this as negative 9 to negative 7. Okay? What that means is we're going to have to extend this for sure, right? Because we're going to go all the way down to negative 9. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So we're down here at negative 9. And then our negative 7 is right here. And our sine axis, like I said before, is where the wave is going to be centered about horizontally. Okay, so this is the line where where it kind of like splits our sine axis from top and bottom, right? So in this case, our sine axis is negative 8. So that means that all along negative 8, negative 8, we're going to have the center. So above here we're going to have the crests, so to speak, and below negative 8 we'll have the troughs. All right, now the next thing we want to do, now that we have a range of numbers, which should be negative 7, negative 8, and negative 9, we need to make our table of values. Okay, so let's make a table of values up here. Okay, and we're going to start out with our starting point, which in this case was 1/2. So we'll do half, 1, 3 halves, 2, 5 halves, which would be 2.5. Okay, and then I think that should be enough for the first wave. Okay, and we're gonna go ahead and write out 3, just so that we can see what the pattern will be. All right, so whenever it's 1/2, we're going to plug in 1/2 in place of theta, and this is where the form of the equation that they gave us comes in handy. Okay, because it's going to be 1/2 minus 1/2 in this first case. Okay, so 1/2 minus 1/2 is going to be 0. 0 times pi is 0. Sine of 0 is 0. So negative 8 minus 0 will just be negative 8. Okay, and I'll work the next one out so you can kind of see what it is that I'm doing when I say this. Now the next one, I'm going to plug in 1. So let's write out the equation using 1. Okay, so we have y equals negative 8 minus sine of pi times x. In this case we said was 1, so 1 minus 0.5. Okay, 1 minus 1/2 is going to be 1/2. So that's negative 8 minus sine of pi times 0.5. And we said earlier today that 0.5 or 1/2 times pi is the same thing as pi over 2. So negative 8 minus sine of pi over 2. So then the question is, where is sine of pi over 2? Ignore the negative, just where is sine of pi over 2? So sine of pi over 2 is going to be up at the top at 90 degrees, right? So what's the y value there? And it's going to be 1. Okay, so that means this is negative 8 minus 1. Negative 8 minus 1, 9. Or negative 9, I should say. Okay, so that means that on our table at 1 we are at -9. Okay, I'm going to do that again, but this time I'm just going to dictate. So 3/2, or 3/2. 3/2 minus 1/2 is 2/2, which is just 1. 1 times pi is pi. Sine of pi is 0. -8 minus 0 is -8. Okay. Then we're going to plug in 2. 2 minus 1/2 is going to be 3/2. 3/2 times pi is 3 pi over 2. Sine of 3 pi over 2 is -1. So then we have -8 minus -1, which is the same thing as saying -8 plus 1. So that would put us at -7 for 2. Okay. Plug in 5/2. 5/2 minus 1/2 is 4/2, so that's 2. 2 times pi is 2 pi. Sine of 2 pi is 0. -8 minus 0 is -8. Okay. -8, -9, -8, -7, -8. So next we should expect to have a -9, right? So 3 minus 0.5. Well, that'll just be 5/2. 5/2 times pi is 5 pi over 2. So that means we're going to go 1 complete revolution. That's 4 pi over 2. And then 5 pi over 2 will put us back up at 90 degrees. So that's sine of 5 pi over 2 is 1. So -8 minus 1 is -9. Okay. And like I said, hopefully by now you can see the pattern. 8, 9, 8, 7, 8, 9, 8, 7, 8, 9, 8, 7, and so on. Okay, so let's just start graphing these. So we're going to start at 0.5, and at 0.5 or 1/2 we said we are at -8. Okay, then at 1 we said we would be at -9. At 1/2 we would be at -8 again. At 2 we said we're going to be at -7. Then at 5/2 we're going to be at -8 again. At 3 we're going to be back down at -9. Okay, and hopefully you can start seeing the pattern. At 3.5 we'll be back at 8. At 4 we'll be back at -7. And at 4.5 we'll be back at 8. Okay, so if you connect the dots, okay, you can see that we've completed 1 whole wave here, 2 whole waves here. All right, and that's exactly what the instructions are asking us for, 2 waves. All right, and this is exactly what we were expecting, because if you remember from the beginning, we said that this was positive sine of x and this was negative sine of x. And remember, when you have a negative out in front, that means you flip it across the x. Okay, so we should have expected it to go down and then up. And in fact, when we graphed it, it's exactly what it did. It went down and then up. Okay, so that's what your sine wave is going to look like for number 6. Okay, so like I said, if you had any questions over that, make sure you write them down. Write them down now, specifically where it was I lost you, what it was you didn't understand, because there's no guarantee that you'll remember exactly what you were confused about the first time around. Okay, I'm running a little bit short on time, so I'm going to do another problem. I'm going to do one from the back, but I'm just going to do one. Okay, so let's look at the back. Okay, and with first period, I know I did number 1, but with second and fourth period, I wasn't able to get to the back. So what I'm going to do for the back of the worksheet now is I'm going to work out, let's see, we're going to work out number 2, okay, on the back of the worksheet. So one thing that I mentioned very early on when we were starting to graph was that sine and cosine are the exact same curve. they've just been shifted over by a factor of pi over 2, right? So that means that we can look at any graph, like this one, for example, that we just did, and we can say that if we were to start from here to here, that is a sine wave, right? Because it starts at the sine axis, goes up, down, then back up. Okay, so I can say that that's a sine wave. Likewise, however, I could say to look at just these 2 points, okay, and this is now a cosine wave, okay? Or I can look at just these, or the interval between these 2 points, and yet again we have a cosine wave, okay? So in other words, when you're looking at sines and cosines, it's very relative to whatever you want. So a sine equation would be just as valid as a cosine equation, so long as you got the amplitude, the period, and the frequencies right. So that's what I wanted to note there. So when you're given those equations on problems 1 through 4 on the back of the worksheet, problems 1 through 4 on the back of the worksheet, they're all sinusoidal waves. So you could write any of those 4 graphs as sines or cosines. However, because they're asking us specifically for a cosine wave in problems 1 and 2, we got to make sure that we abide to that cosine wave. All right, now one thing that I want you to notice, okay, is how this is laid out. So give me a second to get this picture out for you. Alright, so here's the graph on number 2. Alright, so what I want you to look at first is that just by looking at it, we can't tell if it's a sine wave. If we cover up any 2 points, that could be an upside down cosine, this could be a cosine, or if we cover just about there, we could have a sine wave, right? Or for that matter, we could have a negative cosine wave, right? Not a negative cosine, a negative sine wave. Okay, so it's very respective to what you're looking for. Now, because it's telling us to look for a cosine, that means that we're going to need to look for a cosine wave. Now, the one thing you got to remember is that cosines always start at the top, right? Cosine of 0 is 1. So that means that if you were starting at the origin, you would be starting at 1. Okay, so that means that we're going to look at the crests. Now, one thing I mentioned in first period is that with these sines and cosines, there's technically an infinite number of equations that are correct. And the reason for that is because I could choose my TPS, or my total phase shift, my starting point, to be here. I could choose my starting point to be here, or for that matter, I could choose it to be here. So in other words, there's literally an infinite number of equations for any particular sinusoidal wave. So to make things easy, I'm just going to pick, let's see, let's just pick this value here. Okay, now I know it might be a little hard to see. It's probably easier to see on your worksheet than it is mine, but I think I might pick here. But see, the problem with picking this point right here as our starting point is the fact that it's kind of in between 2 nice blocks, so to speak. Okay, so what I might do is I might choose a trough instead, because this trough is starting exactly at pi over 2, right? If this is pi, then halfway right in between should be pi over 2. So I might pick pi over 2 for my cosine, which would imply that this cosine wave is actually a negative cosine, right? Because if positive cosine starts at the top, goes down, and then back up top, that's positive cosine. The negative cosine would start at the bottom, go up, and then back down to the bottom. Okay, so we could start here at pi over 2, or we could even make things a lot more easier and just start here at 0, actually, right? So let's do that instead. because that'll give us a wave that starts at 0, and it'll make our equation a lot simpler. And then once we've done that, I'll go over how you would basically come up with an equation that would start here, or an equation for a cosine that would start here, or an equation for a cosine that would start here. Okay. If we did start up here, thinking about it now, if this is pi over 2, then smack dab in the middle would have to be pi over 4. Okay. But when you start messing with pi over 4s, that's when you introduce radical 2 over 2 and stuff. And I'd rather not mess with that. So I'd rather just start at a nice value for cosine, which will be down here at 0. Okay. So first thing you want to check for when you're dealing with these problems is what's the period of my graph. So how long before I reach the same y value where I started. So if I started down here at 1, 2, 3, 4, negative 4, I'm going to move along the curve, and when I reach negative 4 again, I've completed one complete wave, and that's the period. Okay, so since in this case I have a period of pi over 2, okay, because we start at 0, and then when we complete a whole wave we're at pi over 2, we're going to use pi over 2 for a variety of our calculations, namely what b is. Okay, so let's start out with that. We know that our period t is equal to pi over 2. All right. The other thing you got to remember is that period is 2 pi over the frequency. So the reason that the period is useful is because it allows us to find frequency. Okay. Now we have an equation right here that says pi is equal to 2 pi, pi over 2 is equal to 2 pi over b. So you could cross multiply and divide, and that might get us somewhere. Okay, so let's just do that because that'll probably be the easiest way. So if we cross multiply and divide, we get pi times b equals 2 times 2 is 4 pi. So that means that to get b by itself, we need to divide by pi. So that means that b is equal to 4. Okay, because your pi's will reduce out or simplify out. Okay, so that means that b is 4. So that's one of our 4 pieces. The next piece that is going to be just as easy is going to be our total phase shift, right? Our total phase shift says that it's absolute value of c over absolute value of b. Okay, now since our total phase shift in the case that we have here is going to be 0 because we're starting at 0, all right, we can just say that this will be 0 over 4, which is what b was. We just found it, which is why it's 0. Okay, so if c is 0, or if this is 0, that implies that c is equal to 0. So now we have b and c. Okay, the next two, a and b, require a little bit of calculation to find out. Okay, so let's look at the graph one last time. Okay, and we're going to look at the range of this curve. So this curve goes from positive 2 all the way down to, we said, negative 4 earlier. Okay, so our range is negative 4 to positive 2. Negative 4 to positive 2. Okay, so then we have to figure out what the sine axis d and what the amplitude a is. Okay, now the sine axis is going to be real easy. The sine axis, also known as d, okay, is going to be the average of these two. So negative 4 plus 2 divided by 2. So negative 4 plus 2 is negative 2 over 2 will be negative 1. So what this tells us is that our d value is negative 1. Okay. So if you remember from the front page, the way we ended up with that very last range was we added the sine axis to it. So if we added the sine axis to get to this, we're going to want to subtract the sine axis to go the other way. Okay, so in other words, what we're going to try and do is, in order to find A, we're going to work backwards. So as you're going this way, you're multiplying, right? And then you're adding the sine axis. So when you go the other way, okay, when you go the other way, we're going to subtract and we're going to divide to get our A value. Okay, so let's start out with the range. So we're going to do it this way so it's a little easier to see. We're going to start over here with -4, 2. Okay, and we said that if we're going the other way, we're going to subtract our D value. So since our D value is -1, we're going to subtract -1, which means we're adding 1, right? So we're going to end up with a range of -4 plus 1 is -3. 2 plus 1 is +3. So then the question is, how do I get from that one to -1, 1? Well, I think it's fairly obvious that we needed to multiply by 3, or in other words, divide by 3. So what that tells us is that A is equal to 3. Okay. Now, another thing that you need to remember is that because we chose to start at a negative value, okay, so because we chose to start down here, that means it's going to be a negative cosine. So when we plug this into the equation, we got to make sure that this is actually -3, okay, to make sure that we get that correct flip. So far we have all 4 pieces. We have A, we have D, we have C, and we have B. Now it's just a matter of putting it together. So remember that our equations look like y equals A times, in this case, we're going to do cosine of B theta minus or plus C. And we'll remind us why we don't care if it's minus or plus in this case. It's not going to matter because we're starting at 0. However, if we had started to the right, like we did in problem number 6 on the front, that would have been minus C. If we had started to the left, then it would have been plus C. Okay, and then we're going to add D to it. So now it's just a matter of filling out our pieces. So A, we said, was 3, but because we're flipping it, it's got to be a -3 cosine. B, we said, was 4 theta plus C, which is 0, plus D, which in this case is -1, so -1. So then what our equation ends up looking is like -3 cosine of 4 theta minus 1. Okay, and that would be our equation. So then the question comes in to play as to, well, what if we had picked pi over 2? Well, we could say that y is also equal to -3 cosine of 4 theta, and because we moved pi over 2 units to the right, our C value would be pi over 2. So minus pi over 2. Okay. Well, our inclination would be to say that it would be minus pi over 2, right? But we gotta remember, if it's not, this is our starting position. So this isn't actually our C value, right? This is, well, what we are saying pi over 2 here, this is actually our TPS. So it wouldn't be valid to say this, okay? This is another reason why whenever we're writing equations, that new form that we were given might actually be easier because we don't have to care about what our C value is, okay? So in order to calculate what it would be in this form of the equation, we would have to figure out that the TPS is C over B, which is in this case going to be pi over 2. And if we know that B is 4, then we can say it's 4 pi over 2 equals C. Okay, what you do is you multiply both sides by 4, so you get 4 pi over 2 equals C. So then what we end up with is that C is actually in fact equal to 2 pi, not pi over 2. In order to move from here to here, we have to subtract 2 pi. Okay. So what I'm going to recommend is, here was really easy because we started at 0. Okay, so we don't have to worry about that mess. However, if you choose somewhere other than 0, write your equations using the other notation, which was the a cosine of 4 parentheses theta minus your total phase shift, okay, plus d. This makes writing the equation so much easier, because now all we have to do is plug in our values, which we said were -3 cosine of 4 parentheses theta. And since we want to move over pi over 2 units, okay, we can just say minus pi over 2 minus 1. And now we have a valid equation. This is a good equation. This is no good because that shift is wrong, right? But this is also a good equation. Okay. If we had chosen to start up here at pi over 4 instead of pi over 2 or 0, okay, that would have been a positive cosine. So we would have had something like y equals, okay, we know our amplitude is going to be 3 because we still calculated that, right? The amplitude, the absolute value of the amplitude didn't change. Now it's going to be positive, however, because we're starting up here instead of down here, okay? So since we start at the top, it's positive. If you ever start at the bottom, it's going to be negative. So since we started at the top and we know that it's cosine, it'll be 3 cosine, okay? Your frequency is still the same, 4 parentheses theta, because we're starting at pi over 4 minus pi over 4, close your set of parentheses, and your sine axis never changed, so that's still -1. Okay, this is yet another valid equation. Okay, so this is why I keep saying there are a myriad of different equations that would basically meet the requirements to create this curve. Because when you think about it, all you have to do is cut this piece out and just paste and paste and paste and paste and paste over, right? So if you have the same piece, it doesn't matter where you start, so long as the frequency, right, the period, how long it is, and your amplitude and phase shift stay the same, that starting point can be whatever you want it to be, as long as it lands on one of those increments, okay? And so this is why this form of the equation might actually be a lot better for writing the equation of a graph, because you don't have to take into consideration that C value. All you have to do is think about what your total phase shift is, or your starting point, right? And then just plug in the values. You know that the amplitude is 3, you know that the frequency is 4, and you know that your sine axis is -1. Those 3 things will stay the same. The only things that will change will probably be the sine on the cosine, right? The SIGN on the cosine. And then all that'll change will be the total phase shift, also known as your starting point. Okay. Hopefully that wasn't too confusing. If you'd like, ask to rewind the video and rewatch it again. or if not, like I said, just write some notes somewhere on your paper, on a sticky note or something. Make a note of it so that when I get back tomorrow, you can ask me these questions and I can better explain it. Okay, so good luck. Finish the rest of this worksheet now, and we should be good to start on Tuesday going over the project where we're going to basically make equations, to make these graphs, to create a caricature of some sort, or a drawing of some sort, okay, using sines, cosines, and tangents. All right, guys, good luck, and I'll see you tomorrow.